Good day, ladies and gentlemen, colleagues. Welcome to you all. Welcome to the KISA monthly member webinar. My name is Tim Anton Okai. I'm a clinical engineering lecturer at the Swan University of Technology here in Pretoria, and I'm also in the KISA Education and Training Committee. So I'd like to welcome you all to today's KISA Mindray Medical Collaboration Training webinar. Today we have 3 presentations from Mindray. And Mindray is one of KISA's Gold Corporate members. So 3 presentations lined up, and each presentation is about 1 hour in length. And at the end of each presentation, we'll have some time for Q&A. So please, if you have any questions during the presentation, use the Zoom chat bubble, type in your questions. And at the end of each session, we shall read out the questions so that they can be answered. The first presentation for today is a management course titled Management in Hospital Medical Devices, FEMA Application in Medical Industry. This presentation will be given by Alan Wang. He is Mindray's Southern Africa IVD Service Engineer and is also affiliated to Virginia Polytechnic Institute and State University in the USA. He will be assisted by Wayne Zheng, who is a Senior Service Manager and Chief Medical Engineer, Service Innovation Expert at Mindray. So he will be handling the Q&A session at the end of this first presentation. So, Alan, if you're ready, can we give him control so he can share his screen and proceed with his presentation?
So, good afternoon, everyone. First of all, I wish to thank you for attending this webinar. My topic today, as you can see here, is to have a discussion related to this risk management in hospital for medical device engineering. And more importantly, an effective method that can be used to identify, to quantify, and eventually to reduce the total risk level. The tool, or I would say this methodology we're focusing today, is called FMEA analysis. First of all, I would like to introduce the agenda for my presentation today. We will first go through about what is FMEA analysis, and then why we should use it, and how we can apply it into our works with device in hospital. And finally, a real-world case scenario that we can practice this methodology with. But before I directly jump into this boring official definition of management manual material, I would like to share a short story of Dr. Bian Xue, who's known as one of the most famous doctors in China's history. This is a conversation between doctor and the king. All 3 kids in Dr. Bian Xue's family, they were all good at medical skills. However, Dr. Bian Xue, the most famous among all his family members, believes his medical skill is actually the worst compared to his brothers. In fact, he believed that's exactly the reason why he became famous. Here is how he explained it to the king. He said, "My elder brother's skill is so good that he can identify the tiniest sign of disease and treat accordingly. So only our family members know his superb skill. And for my second brother," doctor said, "he's able to treat disease based on early stage symptoms. So people think he can only treat minor diseases, so that only a few people in my hometown knows his skill. And lastly, about myself," doctor said, "I'm unable to reach my brother's skill level. I gained my reputation because people heard my story of conducting operations, cutting open skins and performing treatment that's visually impressive. So they believe I am the one with best skills, but that's not true. Looking back from today, we cannot say if it's Dr. Bianchue's modesty strategy, but the core logic of his understanding of medical treatment matches with many of these modern ideas.
Successfully.
That the prevention is also the first and highest level of risk management. And that's exactly the core essence of today's topic, the FMEA analysis. The origin of FMEA analysis, or failure mode and effect analysis, is a systematic methodology constructed from experience of identifying possible risks during industrial production. This handbook gives two approaches of analysis mode. Looking from design perspective, the DFMEA, and from process perspective, the PFM. Today, I will introduce mainly the process FMEA as it matches with the medical engineering risk analysis, focus on the medical device itself. This method, FMEA, was originated from aviation industry back in 1950s, used to analyze and reduce risks during aircraft design. After that, it was massively introduced into automobile industry as well. Nowadays, FMEA is a very popular and testified management tool for more manufacturing industry, including our topic today, the risk management in medical engineering. Mindray, as a manufacturer, we care not only the design and production side of our product, but we also care about the full life cycle of it, including these potential risks that could lead to problems when our customers using it, and to help them design and construct a system to identify, to prevent, and ultimately and hopefully to eliminate those risks. Here, some scholar research has been studied in the last 2 decades for hospitals and medical device industry using this failure mode and effect analysis to improve managing efficiency. So from this perspective, FMEA is also well testified in hospital process management as well. And for specific application for medical device in hospitals, we can study or think from the reagent and consumable management, for the device maintenance and device repair management, and also the workflow management, which is to study the human resourcing as well. So you will see this possible, there's so many possible angles to study this. In today's scenario, I will discuss the process FMEA, and that focus on the full life cycle management of medical equipment. So in this previous section, we discussed what is FMEA, and here I wish to use a little more time to explain why we should use this analysis method in our topic for medical device and medical device engineering as well. But you might ask, why we have to use it? Maybe the current hospital regulation is good already. Why bother to switch to this new methodology? Well, here I can answer you that this analysis mode is a good add-on that not only helps reducing the overall risk level, but it's also no need to change significantly on existing hospital regulations. Today, many new technologies and devices has been introduced into hospitals, which brings us conveniences, yet with new potential risks. For example, here we have this Da Vinci operation robot. We also have some remote diagnostic technology introduced to many hospitals. And probably the hospital information management platform we've been using. And sometimes it's a new specific device like the respiratory therapist. With this advanced yet complex technology, we will need a new set of risk managing regulations as the total complexity and the potential failure parties increases. First of all, I wish to introduce some supports this risk management strategy. The iceberg theory, I believe many of you already knew, shows that the risk we can see is only a tiny fraction among all of the risk. Those hidden part of risks are what we really should take care of, especially in hospitals when we are trying to treat our patients with very vulnerable health conditions. And secondly, the Heinrich's law. I believe this is a more quantitative way to explain the iceberg theory. Heinrich, a famous American safety engineer who believes every major accident is not an isolated event. This major accident reveals 29 more similar accidents that had lower negative influences ultimately. And 300 more accidents happened, but luckily no one was hurt. Sorry, my apology. So the actual systematic risk is much higher than the single major event itself. Sometimes we see only one major incident happen because a single event managed to penetrate all levels of existing regulations. But there are more similar incidents being stopped by regulations. But that doesn't mean all the other incidents being stopped does not exist. Based on these two theories, the Joint Commission International suggests each hospital should conduct a forward-looking risk assessment at least once each year to improve overall risk management skill and the precautionary procedure for each hospital. At the end of this section, I wish to bring some key points on how exactly can we make this applicable. From a medical institution scale, we can first analyze from these three aspects from the degree of system, degree of methods, and degree of procedure. After that, we can come down to the medical device itself. We can look for, of course, the device itself. Also, we can consider the operators of this device and the technical systems of it, and even the working environment of this device. Lastly, from the most direct point of analyzing, how to monitor the safety of device operation of patients and how we can record and report in case of emergency. This is something we'll discuss shortly in the next section of how to carry out this analysis step by step. Let's first have a look to this flowchart and steps 1 to 8 for a full FMEA analysis. It might look a little complicated, but the key is the highlighted term here, the RPM or risk value. I will explain it carefully just a little bit later. Right now, I will start introducing this step 1 to 8 on the left side, step by step. Step 1 to 3 is where we get started to set the direction of our entire analysis. First step, we will have to find a specific issue and risk to discuss. For the second step, we will need to list we will need to have a list of individuals who's involved or related to the topic we confirm in the first step. And thirdly, we will need to construct a workflow that we can follow step by step during this entire analysis process. Be aware that the number 3, or actually the entire number 1 to 3, is the foundation of our entire analysis. We would like to have as detailed as much analysis for these first 3 steps so we can have a very useful and meaningful analysis later. For step number 4, in my opinion, this is where this analysis really begins. Here at the first step, I wish to introduce some evaluation indicators as we shown here. Indicator S represents the severity of an incident. Indicator O represents the frequency of occurrence of this kind of incident. And indicator D, the detection level of this incident. Together, the total RPM calculated based on these 3 indicators is a quantified value that can be used to represent the total amount of risks of the topic we were discussing today. Let's first talk about the indicator S, severity, represent the level from no effects to the highest level of negative consequences. The reading represents severity level when this type of risk actually happens. But please be aware that this severity level is directly related to each topic we are studying. For different kinds of risk topic, we will need to adjust, or sometimes we need to fully reconstruct this evaluation standard accordingly. This table, as I put here, is just an example. It's always good and important to adjust it based on your own situation and your standards which you wish to match. Then the second indicator, O, occurrence frequency, also a very straightforward idea that represents the likelihood of a failure to become reality. The more likely this failure to happen, the higher its O rating is. But I wish to bring you a question you can think of every time doing something like this. That is, how much is high or low? This is also based on your own reality and can always aim for industrial standard. For example, when we are studying on a topic that could be a threat to patients' life, the standard, of course, should be adjusted higher if you wish to save the patient's life and to improve the overall risk management result in your hospital. And for the last indicator, indicator D, degree of detection, or I would like to describe as the difficulty of detection. This always represents for whether this risk or failure can be detected and stopped before it's finally become to reality. The harder this risk to be detected, the higher its D value is. For example, we found a highly dangerous risk, but the regulation is well established that we could stop it at the beginning every time. In this case, we consider the risk to have a low difficulty of detection. So this is resulting in a low D ratings ultimately. Finally, we can calculate this number we've been looking for so long, the RPM, or risk value. Once we fully understand and have analyzed all 3 indicators, it's actually very easy to get the RPM. we simply times these three indicators together as this example shown here. The final result, or RPM value, is the total risk level we get from our stated scenario. Of course, we don't stop here. We're not gonna do one analysis for how much problem we have for now and just stop it. After the first round of analyzing on each indicator separately, we have to optimize each section in our workflow from the number 3 step accordingly. After applying these possible or difficult improvement sections, we will need to do another round of indicator rating and to get our indicators, the risk value after improvement. Here is a very straightforward and easy table I constructed. In this example template here, it's easy to understand which indicators we manage to get improvement with. And along with the total risk value improvement, we can also set up multiple failure points to monitor improvement about this project for a large risk model. And one more extra thing, it is always important to standardize the improved workflow to make sure that the improvement in total risk management can be carried out in the future. As I stated before, the risk is always increasing with not only technology and device introduced into a hospital, but also come from new staff you just recently recruit, new business model introduced in the hospital, and other new factors involved into the working environment. So this is always be a dynamic process, and that's why, as I stated before, we recommend to do this kind of analysis at least once per year. And here are some tables from this FMEA manual that can be used to help record the indicators and RPM for each analysis. There are many good-looking tables in the manual to find and to use if you ever need. You can always go to check the official book to find the one you like the most. Okay, so probably the lecture part gets a little boring already, at least I feel the same way. So in the final part, I would like to ask for your participation to analyze a device we're all familiar with this FMEA analysis method we just discussed. Defibrillator is probably one of the most commonly used devices that plays an important role in life-saving. However, this device could also lead to severe injury and even death if operated improperly. I would like to ask you to think about potential risk that could lead to this device. Please feel free to speak up or type in the comment section about any aspect you feel could be a hidden risk resource, and I will browse around and check everyone's feedback in 5 minutes. Well, it looks like probably this example is a little bit difficult or probably too vague to have an actual specific point. So here I would like to share something we prepared before. Hopefully that will bring some mind. Hopefully that will give you some of the hint, some of these fresh ideas. Let me share with you these ideas from our colleague. Okay, good everyone. I'm seeing some very valuable points that your concerns during this example, I will just keep my screen shared for a little longer. So if you found anything that you wish to put into the discussion, we can always add on to that.
Alan, there are a few comments in the chat box. I don't know if you can see them.
Yes, yes, I can see.
Okay, great.
User error, risk about the maintenance, and after sale maintenance cost, something like that. Okay, so let's check the time, and we'll switch to the table I'm using and try to put on this point we wish to discuss. Just in a second. So here, let's see what we have. First one, user error. And number 3, after sale maintenance cost. Also something from outside. I believe this can be something to discuss as well. And here. So I wish to went through each section one by one about its 3 indicators: the severity, occurrence, and the detector level, to calculate our final RPM. So for the first failure from everyone, the user error, how would you identify this severity for this section? You can always share your thoughts in the chat, so we can probably have a understanding to see how everyone see to this question. Yes, actually, I think the term user error is somehow too big. This topic is too big for us to give a proper analysis. I will actually change it into untrained staff. This is a very common problem for user error as well. Yes, and for the risk for the maintenance, probably we can also change to the leakage current. This is a very good point. Leakage current. Yes, this is good. Okay, so let's see. How much of the severity level from 1 to 10 you will rate for untrained staff that's supposed to operate a defibrillators, which is sort of a dangerous machine? If you have to ask me, I will say will be at least 7. Yeah, 7 to 8. It's very dangerous as it can lead to a very strong power surge, a strong shock that could bring a normal people's heart to stop. I would say 8. This is a very good and very good severity level rating. And the occurrence, untrained staff to operate a dangerous defibrillators. How do you think for the occurrence for this kind of situation to happen in your working environment? Is it a very common or it's not likely to happen? Yeah, I would say from 2 to 3. Yes, yes, this is a very good point. If all staff is untrained, then it will be a high occurrence. This is actually very good because we were always saying we have to analyze from our real world scenario. I believe each one of you is having like a different working environment. But in general, if you think this occurrence is high in your specific working environment, then we should put it high. But in general, at least from my own understanding, the possibility of having this completely untrained staff to operate this defibrillator in hospital is relatively low. So I will put it to 3 here for the occurrence. And for detector level, this is kind of tricky. How do you think are we able to detect whether this staff, this doctor is holding this defibrillator? Does he get trained or not? Just from the look. Can you tell? Can you tell whether this? Yeah, this is very tricky. Yes. Can you tell if a man wearing doctor's suit or a nurse carrying this defibrillator, if he's qualified or not? This is very difficult to see from the outlook, from the look. So probably the detector level or the difficulty to detect, 5 or 6. Yes, I'll put it here. So the total number for this section here is 144. Let's come to our second variable, the lackage of current, or like I would probably say a undercharged device, right? A defibrillator that's not properly maintained every day. When we need to use it, it says, oh, sorry, I do not have enough power. The severity, what do you think? Yeah, severity level 9. Yes, I would say probably 8 to 9 because it can lead to a catastrophic failure because we only have like less than 5 minutes to bring our patients back to life. But if it's not charged, we charge it for 10, 20 minutes, the patient is already dead. So yeah, this is a very accurate severity level. For the occurrence, yeah, I see in the chat people say 1 or 2. Yes, this is at least from my perspective, this is not likely to happen every day because with a very good regulation, we can have this possibility to down to low that we have staff to check probably every morning, probably check every noon, 2, 3 times a day to make sure it's not gonna happen. So I would say 1 to 2. Again, this is really depends on your specific level. It does not have to be the same as mine. So that's actually a good point that if you think this case is different from your environment, so there is probably something we need to improve in the next section. And detection level, yes, I agree with you all. The detection level is quite high. If this device is not well charged, it will give us a warning every time, or probably give it a very loud warning. So that it's very hard to, ignore. But sometimes, as we stated before, if it actually happened, it means no one was supposed to look after this machine, and that will lead to a higher difficulty of detect level. Okay, for failure 3, after sale maintenance cost, I'm a little confused about what we could expect of this kind of failure to influence the failure of this total device. But this is a good point. Let's say, if the maintenance cost is high, how severe will that be a problem? Well, let me think. Probably this isn't a very good topic to discuss here. It's not a very clear failure mode. It's just something we can discuss or to discuss later. But it's not directly gonna be a huge threat to the device itself. So I will just temporarily skip this number 3 failure and come to something from my colleague. That the first problem is the machine fails to deliver a shock. This is also, I would say, very similar with the failure 2, that they ultimately leads to an improper operation for this device. Yes, I see some feedback in the chat. Says severity 9, occurrence rate 2, and detect level 7. Okay, this is good. And here left with one last thing to discuss, to practice today, which is this paddle doesn't feed the patient. Even though I am not the professional PMLS engineer, that I know some defibrillators, they requires to use this, I would say, different size of shock paddles for different size of patients. Yes, exactly. If child paddles are used on adults, or the other way, the adults paddle were used for child, this could lead to a unsuccessful shock. And as I know, each time this defibrillator needs some time to recharge and to deliver the next shock. So it could be a quite severe situations. I see something here, the occurrence rate. Yes. Does it affect on the charge joules, or does it affect the effect of same amount of charge joules on different patients? Is it too much, or the position of this different size of shock pedals will cause a inaccurate shocking positions? But yes, I see from the look, this pedal size, they were very different in size. The one for adults and the one for child, probably very low. I will put 2 or 1 here. And for detect level, this is also, I would say, very likely to be detected. As I stated before, one set of paddle for the adult, like a large size paddle, and this paddle for child, they were relatively yeah, it will be detected very easily. So I will put a 2 here. Okay, I see for the maintenance risk, someone said severity 8, occurrence 6, and detect level D. Detect level 8. I will put it here because it's probably not be the best case to put here, but thank you for sharing your idea. So here we see from this table, we add up all these sections together to get a total RPM number here. And this is only the first half of our full FMEA analysis. After every time when you try to conduct your own analysis, please follow what we are doing today. And more importantly, we need to focus what we can do in the next section. After we improve step by step for each of these failures altogether, we do this analysis once again for each failure or each risk. And then we compare the difference between total RPM for before and after. So that's so we can have a very successful and complete risk analysis. So it seems like my time is almost up for my section. I will just switch back to my slides for one last thing. So this is almost the end of my section. And actually, we do not only have this PDC, we do not only have this single analysis or management tool, the FMEA we discussed, and we also have more tools that could be used to help you, like the PDCA and the quality control circle, brainstorming, and root cause analysis, and so many more. If you're interested into it and wish to learn more, please do not hesitate to let us know, and we are looking forward to introduce you more useful skills in the future. And that's the end of my section again. Thank you, everyone, and hopefully to see you all next time. Thank you.
Thank you very much, Alan, for that presentation. I think a virtual round of applause will be in order. Thank you.
Thank you.
And if you still have questions, please post them in the chat box, and we could take the questions at the end of the second presentation. Thank you, Alan.
Thank you.
So now we go to the second presentation, which is a technical presentation titled Mindray N-Series Patient Monitor Introduction. This presentation includes the patient monitor introduction, module and parameter, IT solution, daily maintenance, troubleshooting, technical case sharing, etc. And the presentation will be given by Mr. Leo Lee, a Mindray Senior Lecturer and PMLS Global Technical Support Specialist. Mr. Lee, you're welcome. You can share your screen and commence with your presentation.
Good afternoon, everyone. This is Leo Lee from the Mindray PMLS Global Technical Support Department. I'm the Regional Technical Support Engineer of the Middle East Africa region. Today, I will introduce the Benevision N-Series Patient Monitor. So today, we will start from the following 6 aspects: the basic introduction, common operation, module and parameters, clinical assistance decision, CA function, what we call it. Also the interconnection function, and also some, the last part is the daily maintenance and some simply troubleshooting, also some case sharing, okay? First, let's start with the whole system. here is the overview of our Benevision. Okay. We can see that in our Benevision N series, mainly we have the 3 different types. First one is the we call the separate one. You can see the N22 and N90. We separate the main screen and main unit. Also, here is the SMR, the settle module rack. We can use it to insert our different module, like the multiple parameter module. We call it MPM module. Also, like the other CO2, IBP, etc. Later we will introduce. The second type is the what we call it integrated. It is the N70, N50, and N12. And the last one is the modular. We call it N1. It has the small screen and used to transfer monitor, used as a transfer monitor. It contains the basic 6 parameters and also IBP and CO2 function. Okay, so first one is that for the main screen for all the N series, we have a high transmission screen, so that we are using the optical glued purine technology for the anti-glare interface. So you can see the screen very clearly with the high resolution. Also, for this patient monitor, we have a large viewing angle up to 178 degrees. So in any position, you can get the clear reading effect. Also, we have the light sensor, environment brightness detection sensor. So it will automatically adjust the brightness of the monitor. Also, apart from the display, what are the benefits of our flat screen? You can see our design. We can take N70 as an example. The front side is totally flat without any dead angle, so that during the cleaning and disinfectants is more convenient. Also, we have the design with the no fence design, which means that we will not have any noise inside, and also it can reduce the risk of the hospital infection. And for some kind of the old patient monitor, sometimes with a long time using, it will become yellow and even crack. So now in our N series patient monitor, the housing is resistant up to 49 different types of the cleaning disinfectant to prevent this problem occur. Okay, let's introduce the appearance of the machine. We take the example of the N70. First is the front view. In the front view, you can see that we have a alarm light in the middle of the screen, and also beside the alarm light, there is what we say the environment brightness detection sensor here. And below is the main screen. We have the high resolution. The resolution is as high as 1920 multiple 1080, and the standard with a standard capacitive touch screen. And for different models, N70, it can display up to 12 waveforms, while A50 is maximum 10 waveforms. Also for the N12 is maximal 8 waveforms. And in the bottom of the front view, we have a power switch key, and also we have 2 indicators. One is for the AC power indicator. The second one is for the battery indicator. On the left view, it's very simple. We have a handle which can help you to easily transfer our monitor. And also we have a thermal recorder, which is the 15 millimeters thermal recorder. So you can print the waveform and the report directly. The left view is the module rack. For N70 and N50, we have the 6 module rack. For N12, only we have 4 slots. Here we can insert our parameter module inside to implement different measurement of the parameters. Later we will have in the module introduction we will introduce. Here is the SMR module. We call the full name should be the Settle Module Rock. So from here you can see we have NIBP cost management. So we can put the NIBP cost here when you don't need to use it. Also we have the cable management hook to help you to management the accessory. And you can see we support multiple of the different modules. Here is on the SMR module, we have working indicator to showing the connection. If the connection is normal, is working, the indicator will be light. In the back view, there are 2 different connectors in the SMR module. The left one is for our old generation high-end patient monitor called T-series. And the right one is for the N-series patient monitor. So for SMR module rack, we can be compatible with both T-series and N-series. And here to show you how to insert the module. After you insert the module, you will hear a click beep, which means that it's locked in the module rack. And if we want to remove the module, in the bottom of the module, there will be a button. When you press it, it will help you to unlock the module. Then you can remove it easily. Okay, at the bottom view of our patient monitor, it is the places we install the batteries. From here, you can see that we can install the battery or remove the battery without any tools. It will be more convenient for us. And a little bit different is that the N12 and N50 comparing with the N70, they have the different position for the battery. So for a single battery, at least it can be used for more than 2 hours. And next one is for the back view of our N-series. We will comparing with it differently. First is the N12 and N50. Here you can see that the first one is some of the USB interface. The function here is to the first function is to use for the USB upgrade for our software, for our patient monitor software. And also it can use to help us to export like the logs and the clinical patient data while through this USB connector. And also it can use to connect it to some kind of the tools like the mouse, a keyboard, a scanner. And number 2, I think as an engineer, we all know that is the equipotential jack. And also the number 3 is our AC power supplier. Number 4 is the SMR connector. Its function is we can connect it to our SMR module or the N1 docking. Number 5 is what we call the BNC connector. The function here is to connect it to the nurse. Right? Okay. If you have any question that you can type in the chatting box. So after the training, after finish the presentation, I will explain it one by one. Okay. So let's continue. Number 5 is the nerve core system. So we can connect it to the nerve core system and provide the signal to trigger the alarm. Number 6 is the DVI connector. We can connect it to an external secondary screen. Number 7 is the network connector. The function here is we also have 2 different functions. The first one is to connect it to our CMS central monitoring station. The second one is that we can use the network table also for the software upgrade. For N70, a little bit different. You can see we have the Chrome 2 and Chrome 3, right? So for the Chrome 2, it's the same connector, same function as the N50 and N12. It's for the patient monitor itself. For the Chrome 3, it's especially like a optional function for the iView function. What is iView function? Later, we will introduce also. For the Chrome 3, all the connector is for the iView module. iView is just as you can take it as a simply personal computer integrated in the patient monitor. So the Chrome 3 is the optional function. Okay, after the basic introduction, we can move to the common operation. Okay, this device is also a standard capacitive touchscreen, like the smartphone we use every day. And the initial operation of our device is simpler and more convenient. In addition, this touchscreen supports wearing silicone gloves. We have tested that we can wear a maximum of 3 layers of the medical silicone gloves and can support the touchscreen operation normally. And also, we have what we call the gesture operation. We can use it like a page up, page down with a single finger, just like your smartphone. Also, we can use 2 fingers to swipe it, to slide it left or right, so that we can change the different screen type. Also, if you use 2 fingers to slide down, it is the fast operation for discharging a patient. Let's briefly introduce the display layout of our monitor. The upper part of the screen is that the patient information, configuration information, technical and physiological alarm prompt, and also some kind of the system information prompt. And in the middle, we separate with the waveform area and the parameter area. In the waveform area, a maximum of 12 waveform for N70 can be displayed. And the bottom of the screen is we call the shortcut keys area. So we can see in the screen here, there is a more button, right? So clicking the more button to display up to 28 keys, shortcut keys. Then you can also customize the shortcut keys according to your habits. The operation menu and the screen of our product are flat, and the 19% of the operation can be complete in 2 steps. We can take this ECG setup menu as an example. We can click the ECG parameter area directly to pump up this setup menu. The left column is the classify setup page, and the upper row is the property page for switching between different parameters. The quick arrival display of the horizontal and vertical classification, the user-friendly one click. Here you can see that we have the fast operation of the common function. Okay, the following section, briefly, we will introduce about the admission and discharge of the patient that we mostly used. The unserious patient monitor is used to we have the ADT function to get the patient information directly from the ADT server, so we can have a quick admit for the patient. You can see we have the find patient in the ADT server. Then after admitting a patient, we should enter the patient information as soon as possible. Otherwise, the patient data will be saved in different one. Also, we can control if we connected the patient monitor to the central monitoring station. We can also admit the patient. We can finish this operation in the CMS. Okay. The patient monitor can report various physiological alarms and technical alarms, such as the lead off, such as the low battery, etc. So these alarms are assigned to 3 alarm levels. We have the high alarm, high-end alarm, middle alarm, and low alarm. So here we have a centralized alarm setting so that we can help the nurse to have a quickly modification of the different alarm limit. Okay, so here also we can click the volume shortcut key to set the alarm volume, heartbeat volume, and the key volume. On this screen, you can also increase the high-level alarm volume according to the department requirements. On the maintenance alarm screen, the unserious monitor supports 3 alarm tone type. For example, in the patient room, we have several different devices, medical devices. For example, we have patient monitor, we have anesthesia machine, or the ventilator. So if there is an alarm occur and their sound are the same, maybe at the first time you don't know where the alarm comes from. Maybe it's from the patient monitor, maybe it's from the ventilator. So we design 3 different alarm sound types. So you can choose a different alarm sound, so you can fastly determine which devices is alarming. Also, we have the auto increase volume setup, which means that for some of the high level alarm, when we have the problem, when we have this kind of alarm, the alarm volume will automatically increase. Okay. Also, we have the innovation comparison function here. You can see that we can at the same time you can call up any 2 kinds of the review screen at the bedside and the review of the patient condition simultaneously, such as the alarm event and the full disclosure, or you use the full disclosure and the graphic trace. So the doctors can understand the change of the patient condition in the last 24 hours. You can compare with it. Okay, next is our modular introduction. The monitor and its basic operation are described. So we can move to the parameter modules. So here is the overview of our whole all parameters module from the left to right. First one is the N1, and also we have different version of the MPM module, which means we call it multiple parameters module. Also, we have different separated parameter module like the SpO2, like the AG function, and the CCl gases, and NT, ICG, and so on. So later we can see it one by one. For ECG function in our N serial, I suppose that all the patient monitor can use this function, right? So what's the benefits in our patient monitor, especially in ECG? You know, the early monitoring, the old type of the monitors, basically they will use the single lead ECG monitoring algorithm. When the calculation lead was disturbed, the inaccurate ECG analysis would be lead to a false alarm. But now our N-series patient monitor are using the multi-lead synchronous ECG monitoring algorithm, which can help us to give accurate analysis results according to the status of the, even one lead is disturbed, we can still give the accurate analysis result to the doctors. Another benefit for our ECG is that we have we call it cross-fusion function. What is cross-fusion function? It means that the monitor will automatically fuse the comprehensive analysis of SpO2 and ECG parameters to improve the accuracy of the arrhythmia analysis and heart rate, and also the pulse rate measurement. And also we can reduce the false alarm. So how we can use the cross fusion, you can find in the ECG setup, and we have a displayed cross fusion switch here. So after you switch here, you will see two different signal displaying beside the ECG parameters. So normally, how we can explain how it works. For example, we divide it in 3 different sections. The first one is that both ECG and SpO2 signals are under a good quality. Under this situation, the cross-fusion function will not be enabled because both signals are good. The second situation is that if the SpO2 signal quality is poor, but the ECG signal is good at the same time, the cross-fusion will fuse the ECG signal during the SpO2 signal analysis. So we can provide a correct pulse rate according to the ECG measurement. And the third situation is similar. The ECG signal is poor and the SpO2 signal is good. So we can use the SpO2 reading to, provide a more accurate reading for the ECG, for the pulse rate and heart rate. And since we have different version of the NPM module, so please note that the cross-fusion function must be implanted with the NPM Platinum module. Okay, so next one is for our SpO2 function. Mindray patient monitor N-series can support 2 different brands of the SpO2. The first is the Mindray SpO2. The second one is the Nelco SpO2. Also, we can support the double SpO2 monitoring. So we can, with this function, with this configuration, we can implement the CCHD function. Also, we will have 2 different type of the SpO2 sensor for the finger coat and the earth clips. And also for the new SpO2 sensor now, it supports the IPX7 waterproof and can be washed now for the sensor itself. Okay, IBP monitoring is also implemented by the MPM module or the single slot dual channel temperature IBP module. The sensor, the monitor can provide IBP measurement result of maximal 8 channel. How we can use 8 channel? We need to use 1 MPM module and 3 IBP modules, like this. IBP measurement is applicable to the adult, pediatric, and neonate. And the PAWP measurement main purpose is to, for PAWP is for the only the adult and pediatric, not for the neonate. We also provide the PPV monitoring and also multiple overlapping waveforms. What is overlapping waveforms? It's like this. We can overlap different channels of the IBP waveform so that the doctors can know the different get the different information from this waveform. If the local IBP signal needs to be used for our external devices, for example, IABP, the MPM Platinum module is required. We have the MP1 connector. We have an MP1 connector here. This one can output the signal to realize through the multi-function cable. We can output the IBP signal to other machines. Okay, next module is for the CO2 module. CO2 monitoring, we have 3 types of CO2 monitoring in Mindray products. They are side stream, micro stream, and mainstream module. It is used to monitor the respiratory status of patients and guide their ventilation. The side stream is and micro stream use the constant sampling flow to sample the respiratory gases in the patient respiratory airway, and then use the CO2 sensor built in the module to analyze it. Therefore, they need the consumable of the water trap and the sampling tube, which can be used for intubate or non-intubate patients. And for the mainstream module, it's equipped with an external CO2 module, a CO2 sensor on the airway adapter directly. So it connected to the patient breathing system, and this one only suitable for the intubate patient. And Mindray latest single slot, we called it M02D module, is used for the side stream CO2 module. And sorry, if you are config with the oxygen detection, we can use the CO2 plus oxygen module. We have a maintenance-free paramagnetic oxygen sensor. In addition, if the oxygen monitoring is not used, the minimum flow rate of this module is 50 milliliter per minute. If you are using both CO2 function and oxygen function are monitored simultaneously, the minimum flow rate will change to the 19 milliliters per minute. Okay, so the next part, we move to the next part, the clinical assistant decision. We call it CAA function. On our devices, these tools are similar, like the application on your smartphone. We call it CAA function. And this table is based on the requirements of different clinical departments, and some practical tools are developed. I will give you a brief introduction according to the commonly used screens and CAA tools of different departments. For example, in ICU, normally we suggest using the Hermosite, sepsis site, and infusion view. And in OR, we have a BOA dashboard. It is the balance of the anesthesia to show you the 3 stages of the anesthesia. And also we have the N view. In CCU, we have the function of the ST graphic, pace view, and 24 hours ECG summary. In ER and general department, where we have the function for the sepsis site as well. Also the EWS. EWS is the early warning score. Also we have the GCS, have the CQI, and CPR is the quality of CPR quality index to show you the. We have a special sensor to help you detect the quality of the CPR. Also for NICU, we have the CCHD. As I mentioned before, in the SpO2 parameters, we're using 2 different SpO2 sensors to detect 2 positions of the SpO2 to inflate this function. Also, we have the various display screen for different departments. For example, ICU, we also need to use the normal screen, big number screen, ECG, and 12 lead full screen like that. So we can take ICU as an example. First, here is our big number screen. For this one, the benefit is that even you are far away from the patient monitor, you can see the parameters clearly. Besides the function of sweeping the big number screen with 2 fingers to quickly switch to the big number screen, the N-series monitor also supports the setting of 6 parameters, covering all the basic 6 parameters like ECG, SpO2, NIBP, temperature, etc., and also some kind of the advanced parameters like the IBP and CO2 you can display on the same screen. When the 12-lead ECG is configured on the patient monitor, our N-series can provide the function of the resting 12-lead ECG and supports the printing of the analysis reports, which avoid changing the electrocardiographic monitoring equipment for diagnosis and analysis by the department, and we can provide the convenience for the department. Next one is for the night mode. It's a special monitoring mode to prevent the monitor from interrupting the patient. In night mode, the monitor alarm volume, the heartbeat volume, and the key volume automatically will change to the minimum. And the monitor alarm light brightness also change to the low. Privacy mode is a special monitoring mode. In privacy mode, patient information and monitoring data are not displayed on the monitor to protect the information security. The monitor can enter the privacy mode only after it connected to the CMS normally, and the patient is accepted by the CMS. In privacy mode, the patient monitor still monitoring the patient, but the data is only displayed on the CMS. Okay, next one is the infusion view screen. This one is a small tool developed by Mindray based on the linkage between vital sign and infusion pump information for real-time viewing. It can not only directly relative the infusion pump setting to the drug treatment effect of the patient vital sign on the same screen. It can also help the nurse to frequently set the infusion pump. We can modify the pump setting. Okay. Another important function of our N series is to implement the interconnection function. This one is what we call the M-Connect. Okay, for M-Connect solution, first we want to explain what is the M-Connect. In summary, there is a horizontal and vertical relationship between the information system and the equipment. Okay, so first line is what we call the bedside equipment. For example, we can have the N1 transfer patient monitor, also normal patient monitor like for example, our N70, N15, and also sometimes we have the anesthesia machine, ventilator, infusion pump, or even the TM80, the telemetry. This is the bedside equipment. For the bedside equipment, we can use for example, the patient monitor, we can configure with the Wi-Fi module. So we can connect the patient monitor wirelessly to the CMS, central monitoring station, and through the BanyLink module. BanyLink module is a special module for N-Series. You can see that there are 4 network cable connector on this module. So when we insert the BanyLink module to the patient monitor, we can also combine, for example, the anesthesia machine data, the ventilation data, and infusion view, and infusion pump data to the patient monitor. Then together through the Wi-Fi, we send the data to the CMS module. To the CMS application in our laptop, in our PC. So we can transfer the data to the CMS central monitoring station, and through the central monitoring station, we also have different functions here. For example, we have the mobile server. Mobile server means that we can use a mobile viewer. Mobile viewer is an application you can install in your phone. Then using the mobile viewer to access the mobile server, then we can read the data we can get the waveform from the central monitoring station. Also, we have the CMS viewer, which means that we can, for example, the main central monitoring station in room A, you can also use the CMS viewer in room B to view the room A data. Also, for central monitoring station, we have CS, central station, and also we have WS, workstation, and also the VS, view station. For WS and VS, it need to together work with the CS. Workstation means that we can try to operate the monitor in the CS, central monitoring station. But for VS, view station, is only for viewing. It cannot be operated. That's the difference between CS, WS, and VS, 3 different types. And also through the CMS central monitoring station, we can use e-gateway. It's kind of the you can take it as a standard HL7 protocol, because for different brands of the medical equipment company, their data is different. So through the e-gateway, we can output a standard protocol to tell you how to read our data. Then we can, through the e-gateway, to connect it to our EMR system, and hospital information system. This is the the third party, the different brand, different company provide the hospital information system to the hospital. Then we can, through the e-gateway, to translate our data to this system so that we can combine it together. This is what we call the M-Connect solution. Okay, so next one is the our transfer monitor N1. We can use the transfer monitor N1 to replace the MPM module, the multiple parameter module. In addition, N1 is an important part of the M solution. You know that the N1 monitor have the size of the common module, and it has a small touch screen, 5.5-inch touch screen, and it combines all the basic parameter measurement function. For example, the basic 6 parameters, also the IPP function, also the CO2 function. It can be used as a module to insert into our N series of the host monitor. When the patient needs to be transferred, it can also be directly removed from the host monitor. Therefore, it can be used as a transfer monitor with an independent screen display. This greatly reduces the complex operation steps used to transfer a patient and ensure the safety of the patient. During the transfer, the N1 screen monitors the patient condition in real time, and the medical staff, they can clearly see the monitored parameters from the screen. And if the N1 is equipped with a Wi-Fi module, the hospital has a wireless Wi-Fi network, then the N1 can still be online in the central monitoring station so as to achieve the real-time monitoring without interruption, even if the patient needs to be checked out. Of course, if the hospital has no wireless network, there's also no problem. The full disclosure and 120 hours trade data of the patient in the last 48 hours can be stored in the N1. We have 48 hours full disclosure and 120 hours trade data can be saved in the N1. When the patient transfer ends and the bedside monitor is returned, only you need to do is to insert the N1 to the N series host monitor, which is convenient and quickly. In addition, the patient data stored in the N1 will be quickly uploaded to the host monitor, for example, N70, so that the complete patient data can be viewed during the patient information review. The use of the N1 patient monitor will greatly improve the efficiency of the patient transfer in the department, and it can ensure the safety during the patient transfer. In the for this one is the Benelink module. Okay, so with the Benelink module, the N-series monitor can synchronously integrate the ventilators, anesthesia machine, infusion pump, and even other common bedside devices of different brands and models. We can combine it into the patient monitor screen for displaying, for viewing, data summary, and storage. The monitor can view the parameters, waveform, and even some parameter setting of the integrated device can be changed. The information coverage to reflect the patient's current vital sign, and it will send to the CMS or even the hospital information system synchronously. For department with the advanced information viewing requirement at the bedside, our monitors of the modules N70 or above, like N20 or N90, also support a built-in Windows 10 platform. This is what we call the iView module. It is a small PC system pre-installed with a Windows 10 operation system. You can display the Windows 10 in the full screen model through or a half screen module, or even you can use the external secondary screen to display the iView windows. You can connect it to the hospital information system also to make the beside monitors a powerful information terminal for you to get the viewing the medical record information of all the patients at the bedside. And it also providing the greatest convenience for the comprehensive evaluation and formulation of the patient diagnosis and treatment plan. Okay, you can see we can integrate it. Okay, the last part here is for some daily maintenance and simply troubleshooting, also some kind of the case sharing we have met. Also, we will show you the diagram of the N1, N70, and N22. First is the battery. Okay. Oh, sorry. First is our battery optimization maintenance. For the where the devices works properly, place and here you can see that we have the battery optimization. We need to do this we recommended to do this every 3 months to have to keep the lifetime of the battery. So how to do this is to disconnect the monitors from the patient and stop all the monitoring or measuring. Then we change the battery, continuously providing until the battery is fully charged. Then we use a battery to power the monitor. Then until the patient monitor will automatically shut down, and then we recharge it fully recharge the battery. For the frequency is every 3 months we recommend it. And the next one is about the cleaning method. We should use soft cloth wiping with the water or the ethanol and then squeeze it dry with the normal environment. Then we need to wipe the display. Also, we need to wipe the surface. It is the normal cleaning method. And for the disinfectant method, it's similar to the cleaning one, but for the Only difference is now we don't use the water. Now we use the different kind of the disinfectants. As we said before, we can support up to 49 different type of the disinfectant. So we can refer it in our menu and check in the local market if you have the recommended disinfectants or not. Okay, and the cleaning and disinfectant of the accessory is similar. We're using the water and the 17% of the ethanol. And also the disinfectants is similar. You can find it in the operator's menu. And for the simple problem handling, we have some reminder. For example, for some kind of the abnormal measurement parameters, first we need to check whether the clinical size, if it complains with the clinical side of the patient improvement or not. The second one is that we need to check the operation setting if it meets our requirement. For example, we can check for this kind of different. We can check the alarm. For example, sometimes we take an example like an NIBP measurement. First one, we need to think if the problem comes from the patient. Are they readings normally? The second one is that we need to check if there is any alarm from the patient monitor. And then we need to check if the accessory is suitable. For example, for NIBP, we have different size of the NIBP cuff. So is the NIBP cuff using the suitable one or not? And then we can check if the accessory is normal or not. We can replace another accessory and then confirm they are using normally in another patient monitor. And for the NIBP problem, we also have the, in our maintenance menu, we also have the NIBP leakage test. If the reading is not accurate, we can also use a fluke simulator to help us to verify if the reading is normal or not. The final one is that we have a graphical alarm showing in the, for example, if you meet an alarm in the patient monitor, you can click the alarm to view the details, and then our patient monitor will provide you a graphic to show you what is the possible reason to cause this, to trigger this alarm. So it can help you to have a faster solution for the alarm. Okay, next one is for, since we are all the biomedical engineer, I think you are more interested in our hardware diagram. As we mentioned before, we have we divided N series into 3 different types of patient monitor. First one is the N1, the transfer patient monitor. So you can see that the diagram of the hardware for N1, we have integrated parameter board, and the module and the models of these parameters, we call it M51C, because we have different generation for the parameter module. And now the generation, we call it M51C. Okay, so this is the hardware. We have integrated parameter board, and also for the NIBP function, we have the pump and the valve. Then it connected to the parameter panel. For example, we use the connector to connect to different parameters accessory. Then because we can insert the N1 as a normal module, so we also have an in-frame board for the mainly for this function, for this board, its function is to communicate with the patient monitor. We use the infrared one. So also for the new generation of the patient monitor, we also have some kind of the metal touch point for the to ensure the communication between the module and the monitor. So we provide two different communication methods. One is infrared. The second one is some metal touch point. In N1, also we have the main board, the main function, main control function. Mostly, the signal transfer. Signal calculation measurement is implemented by the main board, and we can connect it to the Wi-Fi module used to connect it to our central monitoring station. And for main board, for N1, we can optional single battery or double battery. So we can have a battery A or battery B. But one thing here you need to know is that since the N1 is a small size, it's used to transfer. So we can only choose one of the configuration. For example, if you want to use double battery, which means that the space inside is not so enough. So the oxygen, the CO2 module cannot be configured. So you can choose only one, the battery, two battery, or one battery with CO2 module. Okay, and then we have the this is the front panel. It contains the display and touchscreen. Also, we have some multi-function connector board and power keyboard. Also, the speaker. Okay, this is the structure, main structure for the N1. Since it's small, it's fully used the internal space. Okay, so the next one is for the N50 and N70. From here, you can also see it's similar to N1, but one thing is different. We don't have the parameter board inside, so we can separate it in different parts. First one is the front shell. It contains the LCD screen, alarm lamp board, and power switch board. So it's similar for N1. And for the back shell, we only have one main control board. And also the Wi-Fi module is optional. Put it on the connected with the main control board. For the main control board, then we need to connect it to the speaker. Independent display board is only for the N17 because as I mentioned before, in the back view of the N12 and N50, they only have one clones. Only N17 can configure with the eye view and independent display. For these two, both is only for the N17. And one recorder also is the optional function. So then we need to connect it to the internal module communication board. We have 4 slots and 6 slots, and its function is to communicate with the NPM module and N1. Also, since here you can see we only have the AC/DC module, which means in our N17 and N50, we combine the main control board with the DC/DC board. So when you met some kind of the voltage problem, for example, when you switch on the LCD screen, you can hear the NIPT pump will have a small noise, which means that the monitor now is normally turned on, but there's no displaying in the LCD screen. Maybe the problem is about the different voltage delivered to the LCD screen, so that you can check in the main board. For our N70, the integration is very high. We integrate the main control board and the DC/DC board. And also we have the battery interface board. It only is for the N12. because the N12 and N70 and 50, they are using the different type of the battery. Okay, so they have different battery interface board. Okay, final one is the N19 and N22. So similar principle, we separated into the front view. So for the front shell, we have the touch screen, LCD screen, LCD module. But difference is that we have the front interface board. So the Wi-Fi module is also in here. We can this one is the similar to, we can also take it as the main control board for the N19 and N22. And also all of the back shell, we have a power management board and interface board. This is the main unit. Okay, so we can connect it with the AC/DC board, battery interface, and battery. Also, we have a Bay Trail main board. This is just for the power management. And also for here, we can connect it to external SMR module. Okay, here is the diagram for the different N-series patient monitor. For some detailed information, if you are interested in, you can refer to our service manual. Okay, so next one is for some simple case sharing. We found a problem during using the telemetry, the TM80. We used the TM80 to pair with the N17 patient monitor, but we cannot find the patient data in the N70, but in the CMS, the central monitoring station, we can find it. The root cause here is that they have different time deviation, which means that on the TM80 we have the the clock circuit to calculate the time, and also we have the N70 inside. We also have the clock circuit. So the time in the TM80 and the N70 is not the same. They have too large deviation, which means that it will cause the misunderstanding from the CMS which time is correct. So therefore, we now release a solution is that for the latest software version now, we add the time synchronization mechanism to avoid this problem. So this problem now will not appear anymore. And the second one is the IBP ROM reading we made in China. The alarm will show you like the IBP exists, the measure limit. For example, you can see that here the IBP reading is -41. And we also have an alarm showing it means the IBP exists, the measure limit. After checking with the engineer, then we found that they are using the compatible accessory from other companies, not from Mindray. It will cause this problem, like our Mindray patient monitor have our original accessory. So we recommended to use the original accessory, because even you are using the compatible one from other company, because of the communication protocol, it will cause sometimes a problem with the compatible accessory. So we recommended to use the original one from Mindray. Okay, and the last one is the screen display abnormal, like this. You can see the screen have different, it's not displaying normally. So after we checking with the engineer, we asked them to use because we have a DVI connector behind the machine. So we connect the DVI connector, use a secondary screen, and that one is displaying normally, which means that the main control board is working fine. Then we think the problem is inside the patient monitor. So we asked them to disassemble the machine and found that the screen cable is loosened. Then we also, after we connected the cable, it fixed. Also from our design side, we optimized we checked the cable connection is no problem. So during this time, for the displaying problem, you can use in two different ways. First one, we need to check if the problem is caused by the LCD screen or not. We can use external secondary screen, the DVI connector, to connect it to an external screen, then to check if the main control board now is working or not. Then we can try to analyze if the main control board is working, the patient monitor is turned on normally. We can try to find out if the problem is from the cable, from the LCD screen itself, like this. So I think all guys, we are the engineer, so we will know how to check this problem. If you have any problem during the troubleshooting, just feel free to contact our Mindray service team. We will try our best to help you solve the problem. So that's all from my side. So let me check if there is any question.
Yeah, I think we have a few questions in the chat.
Okay.
Perhaps you can address them, yes.
Oh.
One question says, do they come standard with a printer or optional?
You mean the recorder, right? For the recorder, that one is the optional one. It's not the standard configuration. So during your purchase, the patient monitor, you need to config with the recorder.
The next question says, are the N-series modules repairable?
You mean, do you mean the module repaired by the internal board? Yeah, I think for the module, it is FRU. So we need to replace the whole module if there is a problem with the module. We cannot repair separately in the PCBA board inside.
And Ephraim says the outlet probes and connecting flex unavailability in the market needs to be looked into. He also talked about the pumping solenoid sensors. Mostly there are problems and they need to be looked into as well.
Mm-hmm. Sorry, I didn't get this point.
Outlet probes and connecting flex unavailability in the market. So he implies that they are not available. The probes and the connecting flex, and also pumping solenoid sensors. Mostly they are maybe problematic. There are problems and need to be looked into. And the final question says, training of end user is required by manufacturer to avoid problems. So that's more of a comment.
Yeah, sure. We will provide. This time is just the online training. I think the most effective one should be the on-site training. We will have the engineer to on-site training for the BME guys. So we will introduce the operation and also the disassemble for the machine. So for the end user training, we will have to avoid this problem. Yeah, sure.
Okay, thank you very much, Mr. Leo Lee, for that interesting technical presentation. I think a virtual round of applause would be in order. If you don't mind, colleagues, thank you very much. Thank you so much.
Yeah, welcome. So if you have any question, just feel free to contact our Mindray team, no problem.
Great. I know we are tired, but we have one more presentation for today. And remember to always post your question in the chat, keep your microphones muted, your videos closed to reduce the bandwidth during presentation, except you're the one presenting. Our third presentation for today is by Ramy Hazem. Ramy is a Mindray senior lecturer and also the Middle East and Africa MIS Regional Technical Support Specialist. Ramy will be giving a technical presentation titled Mindray Ultrasound Zone Sonography Technology Introduction. In this presentation, Mr. Hazem will be discussing the technical principles of ultrasonic zone sonography. He'll give an overview of the Resona R9 ultrasound system, and he will also talk about ultrasound case sharing and ITS overview of the Resona R9 ultrasound system and ultrasound technical case sharing and IT solutions. Mr. Ramy Hazem, you're welcome. The stage is yours.
Thank you. Thank you for such a this introduction. Now, my colleague, I know you are tired, but I give this presentation. Maybe you will be interested about it. Now we will explain Zone Sonographer Technology Plus, ZST. That is our presentation today. Okay. Why Zone Sonographer? Why? What is the Zone Sonographer? Why is the key variable of the sonographer platform? How can we evaluate for zone sonography? Okay, why we use the zone photographer here? Okay, for zone photographer, as you see, for all parameters, it depends on three parameters. What is the three parameters? The three parameters here is spatial resolutions and also for tissue and formatting and also for temporal resolution. Okay, for the key of all of these parameters, we should to focus on such as these three parameters. Okay, what if we increase the spatial resolution? If we increase the spatial resolution, the temporal resolution will decrease a little bit and tissue uniformity will be the same. So the higher spatial resolution, it's mean increase the TX line but decrease here the temporal resolution. Okay, what if we increase the tissue uniformity? If we increase the tissue uniformity, that's mean multi-focus of TX, but decrease also the temporal resolution. So for any ultrasound machines, when we increase some parameters, another parameter, it will be decreased. Okay. In zone sonography, we try to compensate about it. Okay. For ultrasound machine, if we can make comparison or relationship between resolutions and the number of channels. If we increase the number of channels, what happens? The resolution, it will be higher. Okay. Also for frequency and resolution, if we increase the frequency, that's mean the resolution, it will be higher, but the penetration here, it will be lower. So it's a relationship between frequency and resolution and penetration. If we increase the frequency, resolution, it will be increased, but penetration, it will be decreased. Okay. What is our zone sonography? For if we need to know the ranking and the ascending of technology, we started before, okay, since 1960 for mechanical scanning. Then after that, we're going to electronic scanning. Then electronic scan line by line as a digital circuit. But now we use zone sonography. Zone sonography is started around 2004 and still till now by added some feature on site. So for zone sonography is revolutions software deriving to approach the acoustic data, acoustic and image formations the breaks of barrier conventional ultrasound based on innovation channels data processing methods. Okay, let's see this. For left side, okay, this is the conformity of zone sonographer. You can see here, okay, what happened? The image is starting to recognize line by line, but with zone sonographer, you can see here, it's starting by image. You can see here is starting by first images here, then starting for second one, then third one, till image it will be recognized. Okay, so that is the difference between traditional beamformer and zone sonography. You can see here the resolution. So which is better? The resolution here is better or here is better? Of course, when we use zone sonographer, it will be better because it depends on zone by zone, not line by line. Okay, here for traditional beamformer, for old one, okay, and zone sonographer for new one. Okay. What is the difference? Here for traditional beamformer, the data acquired line by line. In zone, it will be zones, so it will be higher to making acoustic acquisitions. Hardware here based on beamformer, but here zone is dependent on software. Okay, so it can be easily upgraded. For limit focal depths and number, here is limited focal depths and number. Here is not limited. We can make full field of view focus. Last one, the speed of tissue. As you know, the speed of tissue in organ is around 1540 meter per second. Here we can make a compensation for sound of speed inside the tissue. So we called for zone sonographer technology plus ZST. Okay. For ZST is depend on this formula. What it can confirm? It confirmed for powerful processing architectures. That is the first one. Then enhance the channel data processing. Okay, and make this 4 barriers. What is this for? First of all is advanced acquisition, then dynamic pixel focusing, and also sound speed compensations and total recall. Let's explain what is this. Here for advanced acoustic acquisition. Here for conventional one, and this for advanced. We can see here. Conventional, as we said, is making line by line. You can see here how to make image is line by line. Okay, for advanced acoustic, it making zone by zone. So which is better? Who's faster? Of course, if we use the ZST here, it will be faster. So the workflow of doctor, it will be higher. Okay. Let's go to another picture. You see this river, okay? That when we take a photo in slow shutters, speed, motion artifact. You can see here no details inside. But if we can improve the temporal accuracy, here we can see the fast shutter speed, which is better. In medicine, in imaging, the doctor he's prefer this left one or right one. Of course, if right one, because he can see a lot of details inside. Here also the imaging, you can see the difference between left one and right one. Here is the resolution, it will be better. The doctor can be investigate a lot of details. So there are a lot of benefits for ZST to use the doctor in ultrasound to how to recognize his photo. Second one for dynamic pixel. Okay, what does it mean by dynamic pixel focusing? Let's explain it by dynamic pixel focusing. You can see at left side. Okay, for left side here is conventional. For conventional, how can it start? It starts like this. You can see 1, or 2-3 point at maximum. Okay, in order to let the ultrasound imaging is starting to make the image. Okay, so multiply focusing is making realize tissue uniformity, but describe frame generally. Okay, what if we use the dynamic pixel focusing? If we can make a dynamic pixel focus, you can see it will be faster, and also the image, it will be high resolution. This is one. So here also we increase the dynamic pixel focusing. Another explanation, you can see here this image, but here no focus. Okay, let's apply one focus. When we apply one focus, here we can see the image by details and other image cannot. What if we can apply dual focus? You can see here, we can see the another part of image. So what is, we can use the dynamic pixel focusing. If we can use the dynamic pixel focusing, all image, it will be high resolution, will be more focused. So we can use it to get out a lot of details. Okay. Another explanation for dynamic pixel focusing. Here for advanced acoustic, it working like this, area by area, making acoustics, then making phase alignment, then it sets all together in order to collect the all image to will be in one image. So an ultrasound is depend on your eyes, is depend on machine resolution. So the Zheng technology is better than the conventional one. Last one, here also for dynamic pixel. Here we can see the image. First one, it take one, second, take another, then another. All image take another a lot of photos. So the phase aligns to make or receive echo data in same phases on every overlapping point. We collect all image, okay, to be in one image. You can see here. That is mean by dynamic pixel focusing. So each part of hardware focus on small area on our image and then collect it together to give me a high resolution imaging. Here, there are different between conventional and dynamic. If we apply a phantom in ultrasound, we can see which the resolution is better, left one or right one. Of course, here in right one, you can see the difference between the point here, okay, is more better than here. Also, the second one, for here, for black dots and left sides, also here it's black dots, which is better. Right is better than the left one. Okay. Also, the improve uniformity. What does it mean by improve the uniformity? Here you can see the tissue. The doctor can see the structures of organ. It's very well better than the conventional one. Next one is sound speed compensation. What does it mean by sound speed compensation? The sound is passed through patients or human is have one speed. One speed is measured to be collected is 1540. Here is sound speed compensation. It can be compensated. So we can use it in different type of image, different type of organs. So the sound speed compensation is processing the channel data area by area, okay? And make a compensations for sound in each area. Then collect it together in order to give you a high resolution, okay? By different type of different speeds for each organ. So the doctor can see which is better image and he can make a compensation from his machine to give him better image. So it then here can be compensation. For all the machines, it's difficult to make a compensation. Then here we collect what is the software decision. The software it can see which is better image instead of doctor. and give the best image display in order to let the doctor make a deeply investigation. Okay, here the difference between conventional one and, as we said, the assumed sound speed inside the tissue, it will be 1540. And here we make it lower than. But here, which image is better? Of course, here and right. Here we can see the dot is better than here. Here is hazy. Here that's just dots. You can see it's dot, but here it's a bit like line. So the dots is very, very important to see it. Also another one, for assumed sound speed, here conventional one is off. And this one, who can I get some more details? Left one or right one? For sure, here for right one, I can see here the portal vein is better than portal vein here. Also for black dots, I can see it here better than here. And another thing for tissue, a left side here, a right side, I can see it better than the left side. Okay, let's go. What does it? The last one of the parameter of ZST. The last one is total recall imaging, TRI. Okay, let's see how can to make image formations by TRI. Okay, here for ultrasound is focus in zone. For first one, focus in first zone. Second, focus only for second zone. Then collected together to be in one image, as we said. Okay, for TRI, here a lot of clinical benefits, like what? Like capability for retrospective and multiply processing. I can make multiply processing. Then make potential offboarding capability. Okay, in order to make extend research in the future. Last one. TRI for stored image. I can make a stored image. And most important things, I can make post scan. Okay. After I freeze the image, I can make a change on our image after post. And also I can eliminate the repeat scanning. So the eliminating the repeat scan also I can did it. How can to make evaluation of zone sonography? Okay, first one, to enhance the channel data processing and also powerful processing architectures. Okay. If we want to increase the zone sonography, it should to be put core engine inside. Okay, that's mean, what does it mean by core engine? CPU. But this CPU should to be have high speed. Okay, and increase maybe more than the computer. It will be reached the speed 175%. And also GPU. We are working in image. For ultrasound working in image. Can CPU only to make uniformity of imaging? No. So we use also in our Mindray machine GPU. GPU, here G, it meaning graphic. So we use two processing. One is CPU and second is graphic. Okay. And also for advanced device, we use FPGA, field programmable gate array. That's to increase the capacity and also increase the processing. It will be higher than 43%. And also another one for memory. We increase the memory in our machine in order to let the frame rate, it will be higher. And also another one, we use the hyper hard disk with SSD and HDD. We put the system in SSD and all patient data and all the storage in HDD. Who's better? So SSD is high speed. Okay, so we put the operating system and also the ultrasound in SSD. So it will give me high speed. And also the data flow bandwidth for data transfer, it will be more than 20 gigabit per second. So all of this use hardware in order to let the sonography working well. So that for Mindray machine, we use such as this sonography with this high specific hardware in order to give me high resolution with high speed. Second one, for enhanced channels data processing, we use here focus on resolution for materials of probes and also for latest innovations, technology, like what? Like chronic spatial synthesis. And also we use high definition scope, and all latest technology, we use it in our machines in order to give me high resolution. And also improve sound speed compensation. Sound speed compensation is very, very important in order to get the better image in which organ I can see the disease, or I can see which details I want to see. And also for last one, for grade processing on 3D and 4D. As we said, we use here GPU. GPU is used to generate the graphics. So for graphics, it need be enhanced, and also it is a graphics, it will be should to be better imaging. So when we using the 3D and 4D, it depends on GPU. Okay, let's see another one for chromatic spatial stasis. Okay, this one, when we make an imaging, you can see here is making one straight and other one is by angle. So it's mean by multi-angles. Let's see it again. Okay, look, this one, straight, then angle, straight, then angle, straight, then by angle. Why? That's using this multiply angle transmission to improve the image quality. Okay, if we can collect all of this, the image, it will be better, and I can see all of details inside the vision. Okay, you can see here without CSS and here with CSS, which is better. Here, more of details, and you can see the image is more homogeneous than left one. High definition scope. For high definition scope, it's meaning to make processing of a channel data multiply, and then high definition scope can improve the details information of the image. Let's start and let's see here for our presentation. Here, the zone technology is already calculated to get the better image like this. Okay, how can to identify the high definition scope? You can see here the image get a lot of image for this area, number 1, 2, 3, 4, 5, and then collect it again. So it collects all this algorithm each other. So that's mean by multiply processing of a channel data of enhancements. So for zone technology, it use also high definition scope. So it give me better imaging area by area and then boxes by boxes, and using all algorithms to be collected in one image. You can see here the left one or right one, which is better. For every image, we said right one is better, but here we make the high definition scope left side is better than right side. Here you can see here any details. It's little bit difficult to see details in this red point, but here I can see some of details. So high definition scope, when I apply it, I can see more details inside this ROI, region of interest. And also it has some clinical benefits. Let's go for make a break challenge for the equations between spatial resolution, temporal, and tissue uniformity. So it's mean by advanced acoustic acquisitions and dynamic pixel focusing. Okay, here we reached by Zheng technology to increase the spatial resolution and temporal and the high uniformity without effect in any parameter. You see here is the difference. Here is spatial, temporal, and uniformity. If we increase the resolution for 3 of them, all of them is being higher. So no effect, no decrease in another parameter. Let's remember what we said in second slides. Here for resolution, okay, and here for number of channel. When we use the traditional processing for channel data here, the increase, the resolution increase around 38%. And between resolution and the frequency, for high scope increase around 40%. So when we use the zone technology, is better than traditional one. That is my first presentation for zone technology. Now we will explain one of our machine which it use the zone technology R9. But before we going to R9 machine, anyone have any question about it? Hello? Hello?
Yeah, I
Okay,
haven't
let's
seen
go.
any question in the chat, so you can go ahead.
Okay, I will go ahead for our machine, which includes our ZST technology. So what we explained to give me high resolution, we put it in my machine in R9. R9 is high-end machine of ultrasound. Okay, what can use this zone technology in our machine, and what is the clinical benefits? Okay, for our machine R9. Okay, for challenges for radiologists. Okay, it will be more challenging cases need to make a clinical diagnosis more confident, and also it will be used for heavy workload with limited labor resources. I don't want a lot of labor resources. I just want radiographer or doctor only. So here need to make clinical practice and more protective, and demand for minimally invasive treatments need to make interventional procedures safer and more accurate. So all of this is under zone technology. Okay. So we can see here for zone DNA is zone technology, what we explained in last presentation. And zone technology, it can be used for all segmentation, not only for radiology, like OB-GYN, BOC, and also radiology, and full track solution. For any track solutions, we use the R technology, Arizona R9 technology. Okay. Our machine, the overview is something like this. Okay. It be using working for Windows 10. So our machine can work in Windows 10. Okay. And for dual floating, it can make a floating of control panel by 6 ways. So for ergonomic and for easy use, it's very, very easy because it's have 6 ways. And also for silent scans, no noise come from our machine. Another thing, for dual wing floating arm, for all doctors who want the arm and the monitor, it will be floating in order to see the better image. He can make this screen to be near him or near patient. So we use dual wing floating arm in order to let the monitor to be floating. And also we have touch screen. This touch screen is very big, and it's the size around 13.3 inch, okay, with high resolution in order to be programmable and order to be more faster for using operator. And also we have a standby battery. For our machine have a standby battery. It can working in a standby mode more than 24 hours. For systems overview appearance, here you can see the LCD monitor. Here's the speaker. For any ultrasound, it should to be have 2 speakers, one from left side and one on right side. And here is a control panel, and his is rotatable knob. This knob, when I press it, I can move the control in left side and also to right side. Also here have a power button, and also for R9 machine we have DVD writer. Why? All of patients, when they make a doctor make an exam, they want to make a backup. This backup, it should to be in DVD or CD. So we have here DVD writer to get it. And here we have the probe ports. Our machine can be carried 4 probes, okay, at same time. And then we can change from it. From the side, we if the doctor want to working as a cardiology, so here we have ECG cable, so we can input here ECG, and during the examination, and I can monitoring the ECG waveform from patients. And this one is USB in order to also get imaging, or also need to make transfer data from machine to BT. Okay, here from left side and also from right side. Here monitor supporting arm, here for storage box, here for gel holder. I can put gel inside here. Here, of course, drop holder, and here electrical ascending and descending. Here we have a small elevator. I can let the monitor and control panel to be ascending and descending. And also here we have for a special holder for intra-cavity probe holder, and here control panel in order to give the instruction to machines, and here storage box, and also for handle in order to move the machine to anywhere, and here for input-output board. An input-output board panel, it contains USB and also Vega to let the machine connect with external monitors, and also HDMI with LAN cable. LAN cable to let our machine connected with the hospital by DICOM, by LAN, by PAX, by HIS, hospital information system. All of this by this LAN cable. And here's the power supply assembly. That is the overview of our machine. For 16 pictures here, we have 4 probe sockets, okay, which have how much element? For 192, okay, and other probes is have 256. That actually is high number in order to give me a high resolution with touch screen operations, and also all basic modes can be supported, and also for advanced mode like iWorks, iPage, iNeedle also supported, and also supported some of specific modes. It's high-end machine, so a lot of modes it can be supported. And this is the physical features of our machine, the net weight, depth, and also for widths and heights. Okay, but let's make now combine between the Zheng technology and also about the features on software. Here, that is the features of software can be only working for R9 with high imaging. Okay, enabling more confident diagnostics, like what? Like iClear. iClear, as you see here, is using ZST technology. That's mean ZST technology will be giving me high resolution. Okay, so here iClear is off. Okay, see now when I turn on the iClear, look here, more details appear here. So the difference between it cannot be working in iClear off and once it working here. So it provides you higher signal to noise ratio. Okay, let's go to see the difference between one we activate Zheng technology here in iClear and this no, which is image is better. This one is better than this one. For gassing flow, here for gassing flow, it can be applicable for all applications. Okay, then to provide me special information in color mode. Here color mode, also for Doppler, I can see here the flow of blood inside the kidney or any blood flow. So for Z technology, ZST technology, it can be used to let me see more details in blood. For high definition scope, here high definition scope, as we said, it can be identify more details in a small area. Here, this is the region of interest. I cannot see the disease here. When I activate the high definition scope here, I can see the disease. So the doctor can make a decision to patient. Also for sound speed compensations, in our R9 machine can be used for sound speed compensation. And here we can see the difference between sound speed is off. Actually, here it's just like cone, echo cone. I cannot find any details. Button right, the details is started to be appear. So I can from R9 machine get excellent image performance. Also for advanced tool, what is advanced tool I can be used? It can be used advanced COS. What does it mean by COS? When I make injection in patient and then take an exam, take an image, I can see it with high resolution and I can identify the physiological disease. Here I can see the elastography. Okay, and here we can use the smart tools. Okay, let's see it step by one. What is the mean by advanced COS? Here for advanced COS, I can make injection for patients and then get an image. So for advanced COS, it can be working in our machine. Okay, and also for Mindray, we have only HIFR COS. That is only Mindray technology can be identify the physiological change inside the patient. Okay, that is the 4 features I can be working by COS under ZST plus technology. Comprehensive elastography. For elastography, our machine, it can be made in full application. No matter what does it mean by what is the difference between applications. It can be working in thyroid, breast, abdomen, and muscle skeleton, and also for prostate. And also it's complete. I can get the elastography is strain elastography and also for shear wave elastography. So for full range for elastography, I can work on it. And also high performance shear wave. It can give me high performance shear wave in order to let me know if the patient has a tumor or not, he has a cancer or not. So ZST is very, very important to investigate the disease. And also for exclusive elasticity tool. We have some tools in order to get better image and good determine of disease. Okay. For elastography here in R9 machine, I can be used for most of probes like breast, thyroid, liver, spleen, and also for prostate. So it's high-end machine, it can be used for fully application. And also it can be support all probes, no matter what these probes. For abdomen, convex probe, pediatric, phased array probe, a small part it's using for all kinds of linear probe with full range of frequency, and also for vascularity, and also interventional. They can use interventional probe like intraoperative, and for urology, I can use the vaginal probe and also muscle skeleton and cardiac. So for whole range for transducers, I can use it in our machine here. This one for making enabling more precise for interventions. Okay, by using advanced tool and also decided the solution by application. Let's see it. Here, a lot of, if I use my machines in interventional ultrasound, we have unique feature in Mindray like UHIT. Okay, that's making 3D ablations planning and guidance and evaluations. And also for COS, we can use it. Okay, and also for fusion imaging, I can combine the image in ultrasound between ultrasound and also CT and MRI. Okay, with high resolution. That is very, very important when I use it in respiratory compensation. Okay, so the ZST, when I put it with high-end model, it can give me all of these parameters and all of these features. Another thing is for eye needle. As you know, when we put the probe on the patients, it's difficult to see the needle. So I can make guidance. If I put the biopsy, it can be make a guidance. You can see here the difference. When I put needle here, I cannot identify it. But on right side, I can identify it. Okay? So I can here deliver focal. I can deliver tumor. I can deliver any things inside. Okay. That is our machine. I give you introduction about it, but I didn't focus for hardware. I just focus for what does it mean by this technology. I already sent this data to Jackie. He will share it with you. Maybe it's a little bit difficult to identify it from first time, but if you read it, it will be useful for you to know what is the latest technology of ultrasound machine. Okay. And that is my presentation. Anyone have any questions?
Thank you very much.
see-
Ramy. There's a question. Go ahead, Ramy.
Okay.
There's a question.
Yeah. Does the R9 have the USB port to download the data or only DVD writer? It have a both. I can download data here from both, from DVD writer and also from USB. Okay, but why I use DVD writer? Because when I exported the image to CD, it cannot be modified again. So it will be, all ultrasound is used. Okay, anyone have questions?
It appears that's all the questions we have for now.
Yeah, okay.
If there are any more questions, we've got some time. Please feel free to raise your hand or type in the chat box, either for the first, second, or the third speaker.
Is the machine got a printer? Actually, not. But if you request the printer, we can provide it. Okay. Here we can provide a lot of printers, like video printer and also A4 printer, and also you can connect your machine to any printer outside by DICOM. Okay, like Canon, Toshiba, whatever. Here in my presentation, I focus on ZST. ZST, that's a very, very high technology. If you understand it, okay, you can see the benefit of it. Okay. Okay, thank you. No more questions?
Yes, it appears that's all the questions we have for now. Thank you so much, Ramy, Hazem. And a big thank you to Mindray and all the presenters, Alan Wang, Leo Lee, Ramy, Hazem. And thank you to Jacques Lee for your tireless effort in helping to organize this. Not forgetting your colleague, Zheng. I know he's somewhere in the background. So thank you for coming. Thank you to Dita, who is indefatigable in helping to organize this monthly webinars. I also want to thank my colleague, Lungelo Manyati, who is in the background, who was also standing by as a host for Just In Case. Thank you all of you who have attended from all over the place. I would like to hand over to Dita just to close the meeting. I don't know if there are any announcements or final word before we close. Dita?
Tim, thank you very much. I think that's everything. I think a big thank you to the Mindray team for sharing this information and training with us. We appreciate it, and I'm sure all our members also appreciate it a lot. Thank you very much.
Thank you all, and that's
Thank
it for
you.
now.
You're welcome.
Thank you, Jackie. So have a nice day, everyone, and all the best.